All right, my friends, so this is page 14 and 15 that we are working on in our division packet. The first one's done for us using the algorithm. But what I would like to do is show you and remind you that you have other options. If you are totally understanding the algorithm method, I would highly suggest using that. That is the fastest way. But if that's still confusing for you and you're making mistakes and having a hard time with the algorithm, then maybe you like the box method better and you want to try that. Or the partial product or area model can also be used. So what I'm going to do is I'm going to give you a little reminder in this video about how you can use other strategies. Now in class we are going to be going over some of these problems and doing the algorithm together. But if you really don't get the algorithm, you can watch this video and it's going to remind you how you can use other strategies. So again, for the first problem, if I wanted to do this first problem in the box method, I want to show you how that would relate. I can see I have three digits, the hundreds, the tens, and the ones. So when I set up my box, I need to make it a little longer because I need to make sure I have the hundreds, the tens, and the ones. I know I'm dividing by 2, it's my divisor. And then I have 300, 10, and a 4. So 314 is my number. So now if I think about my steps, I know I'm going to divide first. And what I'm asking myself is 2 times what gets me as close to that number without going over. So 2 times what? Well, 2, 4. Okay, 4 is too big. So obviously the answer is 1. Because 2 times 1 is 2, so I would subtract, I'd get a 1, and I go, okay, I compare, it's definitely less than my divisor, so I'm going to bring that over. Instead of bringing it down, we bring it over. Now I have an 11, just like I do here. See my 11? Same thing. So now I've got to repeat. 2 divided into 11. 2, 4, 6, 8, 10, whoop, 12's too big. Must be 5. 2 times 5 was as close as I could get. That's my division. Because remember, that's the missing factor. So 2 divided into 11 is 5. Because 5 times 2 was 10, which was as close as I could get to that 11. I have 1 left over after I subtract. So when I compare, I can see it's definitely less than my divisor. So I have 1 more to unbundle. I'm going to take that 110, bring it here, making 14 ones. Hey, that looks familiar, just like my 14 ones here. You can see it. Then I would say 2 divided into 14. So again, skip counting, however you need to do it. I'll give you a second. I bet you know the answer. Yes, it's 7. Because 2 times 7 is 14, I can't get any closer. And since this whole page has no remainders, I know I should always end up with a 0 at the end. We will get to remainders, but right now, it should always have a 0 at the end. And we can see how this box method matches. Okay, so you might want, if you would like to do this page the box method way, I still want you to practice a couple times with the algorithm, but you are more than welcome to use that box method if that is easier for you. If you are a person and you really struggle with your math facts, that partial quotient might be another way. So I'm going to show you on the next problem how you could use it with the partial quotient. So I'm going to set it up. The partial quotient is very different in the fact that we get to do something special. So I'm going to move this over so you can really see this better. So what I'm doing when I do partial quotient is I'm multiplying 2 times something, and I want to actually think, instead of thinking of it as just a 7, I'm really thinking of it as a 700. So I've got to use my zeros trick, and I think, how close to 700? All right, well, it's kind of a 7. So if I said, well, 2 times 3 is 6. So if 2 times 3 is 6, 2 times 30 is 60. 2 times 300 is 600. Okay, so I've now figured out that I can do 2 times, I'm going to take 600 away. And that's going to leave me with 7. Oop, not 7, silly Miss Stainer. That's going to leave me with 152. Oh boy. Well, I still have to multiply by 2. So now I'm going to think about this 152. I don't know, 2 times what is 152. So I'm going to think about it as a smaller amount. Maybe I want to think about it like 100. 2 times what is 100? Okay, well, that's an easy way. Maybe I could think, okay, well, 2 times 100 is 200. So what about 2 times 50? I could try bigger numbers. So there's a lot. You could always, if you don't know your math facts well, you could always use 2s, 5s, 10s. You know those, okay? So one option is to use a 5. And so I'm not going to use just a 5 because that would only be 10. But if I use 50, then I know I'm going to be able to take 100 away. All right, but that still leaves me with, oh, but look. 2 times what? All right, well, 2 times 2 is 4. That's pretty close to a 5. 2 times 40. Oh, wait, 2 times 40 is too big. But what about 2 times 20? Oh, let's try that. I can do it 20 because 2 times 2 is 4 plus the 0. That was a 40. Well, now I have a 12. Okay, 12's much easier because I can just skip count by 2s. 2, 4, 6, 8, 10, 12. It's 6. 2 times 6, and I have no remainder. So here's where it gets a little tricky because what I have to do is take all those numbers and add them up. And if I don't have them lined up, I might have to do that in a different way. Now, personally, I know I can add some of these together in my head. Maybe I want to do my 300 and my 50 because I know that's going to be 350. And maybe I want to do my 20 and my 6 because I know that's going to be 26. Then when I add them all together, it's a little easier because I'm only adding 2 numbers. So I grouped those and I grouped those. So now I only have to add those. 376. So my answer is 376. So if the partial quotient is the way you like to do it, you can try this page that way as well. But I really want you to try doing the box or algorithm. That's really the best and fastest way. But if you don't know your math facts well, this is another strategy that you can use. You can see how I'm just taking more and more away till I've taken all that I can. Okay? So again, little video to get you thinking. So when you're looking at page 14, you can see that we're going to do a couple of them together. And on page 15, we're going to do the same thing. We're going to do a few of them together. And then you're going to try the rest. So you get to decide. So let's look at page 15. And we're going to do one of these, the box method, just so that you can see both ways. So I can see that my number is 3 divided into 414. So when I set it up, 414, I know my box. I'm going to make it a little bigger because I didn't make it big enough. Should have 3 places. I'm dividing by 3, 414. That's my problem. So if I think about my steps, I can use my card if I need to. So I would say 3 divided into 4, well, 3. Here I'm thinking 3 times something gets me as close to that number. Well, there's only 1. So 3 divided into 4 is 1 because 1 times 3 is 3. Now I can subtract. I get a 1. I compare. It's less, so I can bring over. So I'm going to unbundle that 100 and make it into 10 tenths. So now I have 11 tenths. So 3 divided, now I'm just going to treat it like an 11 though. Okay, 3 divided into 11. 3, 6, 9, 12's too big. Okay, so I had 3 3s. So 3 divided into 11 is 3 because 3 times 3 is 9. And that was as close as I can get. So I can subtract and see what I have left. I would get a 2. When I look at that 2, I compare it. It's less, so I know I've got as close as I can get. Now I can unbundle and bring it over. So now I have 24 ones. 3 divided into 24. I got to sing my 3s song. Sing it. Hopefully you got the same answer I did, which was 8. 3 divided into 24 is 8 because 8 times 3 is 24. Can't get any closer. I get 0 after I subtract. I compare. It's less. There's nothing to unbundle. my answer to that problem, the first problem on page 15, is 138. So if you choose to do it the box method and you want to do it on a separate piece of paper, I want you, if you do it on a whiteboard and you make a mistake, you're never going to know the mistake you made. So you really want to do it on a piece of paper so that when we check our work, we can make sure that you know if you made a mistake. And then all you have to do over here is fill in your answer. And if you want to try to, you can think, okay, I know I can do this. 3 divided into 4. Okay, so that's why my 3 goes here. My 1 after I subtract, and then I can see I bring down the 1. There's my 11. So you can try to relate these two together so that you're understanding how to do the algorithm at the same time as you're using the box method. So hopefully that helps you. Good luck, my friends.